All right, last time we looked at our molar road here, and we talked about how we get between particles and moles, mass and moles, and volume and moles, and then we can make several trips, and I can figure out how many particles there are in 25 grams of something, or what the volume of a given number of particles is by going through not one, but two different conversion factors. And that's all well and good, and that's useful if we're staying within one substance. But what if I need to know, like, if I react 5 grams of something, how much of the something else am I going to get? And well, we've learned how to do that with moles, but moles are great. What if it's, I need grams, right? We talked about how I can't go measure a number of moles. I don't have a mole meter. I have to get it into mass or probably volume. And then it's nice to know the particles. Okay, so what we're going to need, this will only get us around within one substance, right? And I could use a second one of these to get me around within another substance. Or we could have, ta-da, this. Okay, oops, let me scoot that, okay. Right, what if I had 2 of them? I basically just took my original molar road, rewrote it, flipped it over, and stuck it there. Okay, so they're the same thing, but this is going to let me get from one substance up here to a second substance, and that's what my molar avenue is. So each of these molar roads refers to a single substance that we're dealing with. Maybe one is water and one is sodium hydroxide. Or maybe one of them is a piece of metal and the other one is an ionic compound that gets produced. Okay, it's going to work exactly like our original molar road is, where I figure out where I want to start, I figure out where I want to end, and then I draw a line and I figure out what conversion factors, what equalities I need to go through to get there. Okay, the one that's going to allow us to switch roads, to go from the road to the avenue, is this molar ratio. And we talked about this before, that our molar ratios come from a balanced chemical equation. Okay, that we can take an equation that has coefficients, and those coefficients will tell me how many moles of one thing will react with how many moles of another thing. Okay, so examples. Okay, question number 1 then. Let's scoot that there. Okay, perfect. If I want 10 grams of nitrogen to react, what mass of hydrogen gas will also react? Okay, so something that is kind of helpful here is the 2 substances I need are nitrogen and hydrogen. So I'm going to label my molar road. I'm going to say that molar road down here is going to be my nitrogen, and my molar avenue is hydrogen. Okay, and then I'm going to look at what I've got. Well, I'm told 10 grams of N2, so that's where I start, is the mass of N2. Okay, and then I'm asked for what mass of hydrogen gas. So I want to go to the mass here of hydrogen. We're going to end here, okay, and we trace our way through. We go through this molar mass, we're going to go through a molar ratio, and we're going to go through another molar mass. Okay. Notice that those 2 molar masses are going to be different numbers. One refers to the nitrogen, one refers to the hydrogen. Okay, and then I also need to go through this molar ratio. Okay, so we're going to start these just like we have started everything else, with a nice long line. We take the number out of the question, write it right here, 10 grams N2, and a happy face to make ourselves feel better. Okay, so I smeared my thing. First equality we're going to need is a molar mass for nitrogen. Okay, I did not calculate these beforehand, so we're going to round. 1 mole N2 is equal to about 28 grams N2. You have to use the full number, but for right now, we're going to use the rounded version. Okay. I've got mass here, right? Grams, so I want to put the 1 with the grams on the bottom, so that's 28 grams N2, and then the moles, 1 mole N2. 2 goes there. Okay, so that has gotten me so far through my molar mass, okay? And now I'm sitting right here on moles of N2. Now I want to convert up here to moles of H2. That is a molar ratio. Molar ratio is going to come from this balanced chemical equation right here. Okay. I can see, using the coefficients, that 1 mole N2 will equal 3 moles of H2 gas. Okay? So I've got moles here, but both of those are moles, right? So which one needs to go on the bottom? Well, it's moles of N2. This is why I've been telling you that you have to put that formula onto every substance so that we can keep track of that. I have moles of nitrogen here, so I want moles of nitrogen here, right? That's 1 mole nitrogen here, okay? And then there's a 3 here, 3 moles hydrogen there, okay? Not there yet, but we're making progress. Okay, now we've made it up here to this molar avenue, and now I need to go from these moles of hydrogen to mass of hydrogen. So again, I'm going to need a molar mass for hydrogen, which again, 1 mole H2 is equal to about 2 grams H2. I've got moles H2 here, so we'll drop the moles of H2 to the bottom and put the mass on the top, 2 grams H2. Okay, so we come back with our calculator and we say 10 grams. Okay. I like to do it in order, so this is on the bottom. We're going to divide by 28. We're going to multiply by 3 because it's on the top. We'll divide by 1, but we're not putting that in the calculator. Okay, we'll multiply by 2, then we'll divide by 1. Okay, and that will give me an answer of 2.14, and this final unit up here is what I have grams of hydrogen. Okay, let's try it one more time. Okay, notice I didn't bring a rag over today. All right, so if I need 75 liters NH3, how many molecules of H2 will have to react? Let's look and see where we are. Okay. I said that we have 75 liters of NH3, so I like to put the start point on the bottom. You don't have to. Okay, and we're going to start down here at volume. Okay, and then we're going to go to how many molecules of H2. Molecules are a particle, so we're going to end up here, and this will be my H2. Okay, so I'll need to go through the 22.4, through a molar ratio, and up here through the 6.02. Sometimes kids get caught up with the molar masses, that oh, we're going past molar mass, but we're not turning down that road, so we never have to go through this gate. Okay, we'll go through the 22.4, we will go through the molar ratio, and you will go through the 6.02 times 10 to the 23rd. Okay, in that order. So we'll draw a line and put our starting point, 75 liters N2. Okay. Our first equality was 22.4, 1 mole, oops, NH3, I'm not paying attention, NH3, sorry, was equal to 22.4 liters. Okay, I have liters here, we want liters here, 22.4 liters NH3, sorry, is equal to 1 mole NH3. Okay, my next equality was my molar ratio. That's going to come out of the balanced chemical equation, which was up here. Okay, so I know that 2 moles NH3 was equal to 3 moles H2. Okay. So I have moles of NH3 here. We'll drop them to the bottom, take this number, 2 moles NH3, okay, 3 moles H2. Okay, not there yet. Our last equality then was the 6.02. Okay, but we're dealing with hydrogen now. So 6.02 times 10 to the 23rd molecules of hydrogen will equal 1 mole hydrogen, right? I have moles on the top, so we'll drop them to the bottom. 1 mole H2, 6.02 times 10 to the 23rd molecules H2, like that. Okay. Calculator, 75. This is on the bottom, so we'll divide by 22.4. Here, I'm going to multiply by 3 because it's on the top. I'm going to divide by 2 because it's on the bottom. And then I will multiply by 6.02, and then I'm going to push this little button, this little button here that says EE, and then 23. Okay. I get an answer, which says that we have 3.02 times 10 to the 24th molecules H2. Just like that. Okay then.